Now we move on to the final topic. This would be the last video for the term 3 exam. And before I start with the video, I want to dedicate my term 3 videos of this term to my 12 advanced class. They are one of the best, and I'm really gonna miss them. I have been teaching them since when they were in grade 9, term 3, and it has been such a nice journey with them. It was an amazing 3.5 years with them, and I'm really sad that next year they'll not be in the school. But I wish them all the best. I'm not going to mention any names, all my 25-year students, each one of you, and also the students who change their schools. I'm not going to mention any names because of privacy issue and stuff, but it's gonna be different. But I'll really miss you all, and I just wish you all the best wherever you go. Do great. Now then, we will continue with the last video. It is about real world problems. Now we have a real world problem. In fact, this is an easy one. Say, suppose a bacterial, it's about population, by the way. Suppose a bacterial culture initially has 400 cells. After 1 hour, the population has increased to 800. Assuming exponential growth, determine the population after 3 hours. Find an equation for population at any time. And what will be the population after 3.5 hours? So now what you basically do is you need to understand what's given. So initially at zeroth time, y of 0, it is 400. They have told initially that was the thing. At the time 0, you already have 400 cells. But after 1 hour, let's take 1 time as 1 hour, y of 1, it becomes 800. So you can see at every hour it's doubling. So the population is multiplying, right? So now over here doubles. Then what will be the next thing? See, after 1 hour, it's 400, 800. It'll multiply. After 2 hours, it's 1600. Again, it'll be the same thing. It'll multiply after 3 hours, it's 3200. Since they asked only till 3 hours, we will stop. But if they are asked 4 hours, it'll be 6400 and so on. Now, that is the population after 3 hours. That's it. The part one is done. A is done. What about write an equation for population at any time? So now we have to use the exponential growth formula over here. This is very important. Y of t, y of any time t equals a e to the power kt. Now a is the initial population, k is the constant of population growth, and t will be the time. Now what do we know? We know that initially at zeroth time it is 400 cells. So substitute and let's find the a value. Just double checking. 400 equals a e to the power k into 0. What is anything to the power 0? It's 1. So this is gone 1. So a value is 400. So we can write a as 400. That means y of t equals 400 e power kt. But do you know what is the k value? No, let's solve for that now. All you need to do is take the other equation. When 1 hour, you know it is 800, right? Let's put y of t as 1. T as 1. So at y of t of 1, it was given, it's 800. So I'll substitute 800. Here it's 400 constant, e, k, and time is 1. Now let's divide both the sides by 400. You will get 2. Here it goes and e to the power k into 1. This is basically e power k. How can you remove exponential function? Take natural logarithm, because natural logarithm is having base e, and whenever you have something like this, we know from natural logarithm properties, this whatever is the power comes over here and this cancels off. So over here we can just take natural logarithm on both the sides, and what is remaining? It will become natural logarithm 2. Over here, ln e is dissolved. K into 1 is k. So that's it. So we found the k value, a value. All you need to do is substitute back because they have told any time. So t must be written as t itself. Now y of t equals 400 e to the power natural logarithm 2 into t. That's the second part. And now the last one, what will be the population after 3.5 hours? All you need to do is put 3.5 hours over here. So just this, why this the equation we just now solved for, and you need to just substitute 3.5 hours instead of time, and then you will get around 4,525 cells. So sorry, I'm sorry for that. Okay, that's the answer. But remember this 4,525. Let's just go back over here. You can see it was 3,200, and then it's between 3.2 and 6,400. Yes, absolutely. So this is the correct answer. That's how we solve it. Now there are some other problems. This is same, but some similarly they'll tell you different values. It's just changing the values. Or they'll ask you when will it reach? Say for example, what time does it reaches? Say 5,000. All you need to do is substitute 5,000 instead of y of t and solve for t. And you can directly, once you substitute, write the given and everything, the formula, you can directly solve it in the calculator. So you can, or you can show the steps. It's very simple. Take this to the other side and solve, or you can do it in do it in the calculator to check your answers. So simple variation of all the problems, very easy. Try it by yourself and then check the answers. All the answers are over here for A, B, and C parts, and this is the answers over here. You can pause it and check it through, and over here as well, and the last two over here. Sorry, last one over here and over here. So please do try them by yourselves, and this is the final question. Okay, all done now. So that is it. I wish everyone all the best who are writing the exams soon. Um, Please do not panic. Just take time, read the question, be free, clear your mind, and try your best. So, first is the exam, writing exam. Try your best in the writing. So, make sure when you're practicing, write and practice. Doesn't matter which exam it is, which part it is, one, two, or three. Write and practice so it'll be imprinted in your mind. And I just wish you all the best and do well, guys. All the best. I hope everyone gets great marks. Take care.